What if we could go beyond the stars, beyond the Milky Way, and explore any galaxy in the universe? Imagine it, standing at the edge of our solar system, looking out into the vast expanse of space. Behind you is everything we've ever known: Earth, Mars, Jupiter, Saturn. But ahead of you lies something far more incredible: 2 trillion galaxies, each one a collection of billions of stars waiting to be explored. That's more than all the grains of sand on every beach on Earth. And each one of these galaxies is unique, with its own story to tell. Some are massive spiral galaxies, like our Milky Way, while others are small and irregular, shaped by cosmic collisions and gravitational forces we're only beginning to understand. Inside each one of these galaxies lies an entire universe of possibilities. Imagine worlds with purple skies and twin sun, where alien life might have evolved in ways we can't even imagine. But here's the thing. Right now, we're stuck. Our fastest spacecraft, like the Parker Solar Probe, would take tens of thousands of years just to reach the nearest star system, let alone another galaxy. We're like ancient seafarers, gazing at distant horizons with no way to cross the vast oceans before them. But what if that changed? What if we could actually travel to any galaxy we wanted? So, let's talk about how we might actually do this, because it all starts with understanding just how massive our playground really is. Imagine bringing this vision to life with powerful narration. With 11 Labs, you can create lifelike AI-generated voices to tell your stories just the way you envision them. Whether it's for YouTube videos, audiobooks, or podcasts, 11 Labs gives your words a voice that captivates. Start your storytelling journey today. When we talk about galaxies, we're dealing with distances that are hard for the human mind to comprehend. Let me put this in perspective. If you could shrink the Earth down to the size of a marble, our entire solar system would be about the size of a small city. But our galaxy, the Milky Way, would be as big as North America. And that's just one galaxy. Our Milky Way is a massive spiral of stars, gas and dust, stretching about 100,000 light-years across. Now, a light year isn't just a fancy science term. It's the distance light travels in 1 year, moving at an incredible 186,000 miles per second. To give you an idea of what that means, when you look up at the night sky, the light from even the closest star outside our solar system left there 4 years ago. Some of the stars you see sent their light towards Earth before humans even existed. If you wanted to travel to the edge of our own galaxy, just our galaxy, at the speed of light, which, remember, is the fastest anything can possibly go according to physics, it would take you 100,000 years. That's longer than all of recorded human history. And if you wanted to visit our nearest large galactic neighbor, Andromeda, at light speed, you'd need to travel for 2.5 million years. Even if we could build a spacecraft that traveled at 1/10 the speed of light, which would already be an incredible achievement, a journey to Andromeda would take 25 million years. That's about 10 times longer than the entire span of time since the extinction of the dinosaurs. And Andromeda is just our next-door neighbor in cosmic terms. Most galaxies are hundreds of millions or even billions of light-years away. But scientists have been working on several theoretical ways we might actually be able to make these journeys possible. The first is something called a warp drive, and it's not just science fiction from Star Trek anymore. Back in 1994, a physicist named Miguel Alcubierre came up with a mathematical model for how we might actually bend space-time itself to travel faster than light without breaking Einstein's rules. The idea is pretty wild. Instead of trying to move through space, you create a bubble of warped space-time around your spacecraft. The space in front of you gets compressed, while the space behind you expands. It's like surfing a wave of space-time itself. You're not actually moving faster than light within your local space, but the bubble you're in is essentially riding a wave that can move faster than light. And get this, in 2021, scientists actually created what they called a real warp bubble in a lab. Now, it was microscopic and not anything we could use for travel, but it proved that the concept isn't completely impossible. It's like the Wright brothers' first flight, a tiny achievement that hints at much bigger possibilities. But warp drives aren't the only game in town. There's another possibility that's equally mind-bending: wormholes. These are theoretical tunnels through space-time that could connect two distant points in the universe. Imagine folding a piece of paper in half and poking a hole through both layers. That's kind of what a wormhole would do with space itself. Instead of traveling the long way around, you'd simply slip through this cosmic shortcut. The crazy thing is, Einstein's equations actually predict that wormholes could exist. The problem is, they'd be incredibly unstable and would collapse the moment anything tried to pass through them. To keep them open, we'd need something called exotic matter, and don't confuse this with dark matter. They're totally different things. Dark matter is the invisible stuff that makes up about 85% of the matter in our universe. We can't see it, but we know it's there because we can measure its gravitational effects on galaxies. Exotic matter, on the other hand, is way weirder. It's theoretical stuff that would have negative energy density. Basically, it would fall up instead of down and push things apart instead of pulling them together. We've seen tiny hints that something like this might exist in quantum physics experiments, where particles briefly behave in impossible ways, but creating enough exotic matter to hold open a wormhole big enough for a spacecraft. That's still in the realm of science fiction. But let's say we can't figure out warp drives or wormholes. There's still another option, although it's a lot slower: generation ships. These would be massive spacecraft designed to support human life for hundreds or even thousands of years as they make their way to distant stars. Think of them as artificial worlds, complete with their own ecosystems, farms, and everything else needed to keep a population alive and healthy for multiple generations. The challenges of building such a ship are enormous. You'd need to create a completely self-sustaining environment, deal with cosmic radiation, maintain genetic diversity in the population, and solve countless other problems. We've actually tried experiments like this with Biosphere 2, where scientists lived in a sealed ecosystem for 2 years. They faced all sorts of unexpected problems, from oxygen levels dropping to crops failing, showing us just how tricky it is to recreate Earth's delicate balance. Now imagine we've solved all these problems. What would it actually be like to travel to another galaxy? Let's take that journey together. Our first stop would be the edge of our solar system, where we'd pass the Voyager probes, humanity's first emissaries to interstellar space. These ancient spacecraft, launched in the 1970s, carry golden records with messages from Earth, just in case any alien civilization ever finds them. It's like a cosmic message in a bottle, telling whoever might find it who we are and where we came from. As we leave our solar system behind, we'd enter what's called interstellar space. This is where things start to get really exciting. We'd pass through vast clouds of gas and dust called nebulae, where new stars are being born. The Orion Nebula, for example, is a stellar nursery about 1,500 light-years from Earth, where about 1,000 new stars are forming right now. We might see protoplanetary disks, rotating clouds of gas and dust around young stars where new planets are forming. These disks form because of the same physics that makes pizza dough flatten out when you spin it, except instead of a pizza maker's hands, it's gravity doing the work. And then there are the really dramatic sights, supernovas. These are massive stars exploding at the end of their lives, releasing more energy in a few seconds than our sun will produce in its entire lifetime. Take Betelgeuse, for example. It's a red supergiant star that could go supernova any time in the next 100,000 years. When it does, it'll briefly shine brighter than all the other stars in our galaxy combined. But the real show starts when we leave our galaxy entirely. Imagine looking back at the Milky Way from the outside, something no human has ever seen. From this vantage point, you'd see a vast spiral of stars with bright arms swirling around a central bar of densely packed stars. Our sun would be just one tiny point of light among hundreds of billions, tucked away in one of the outer spiral arms. As we venture into intergalactic space, we'd encounter something else: dark matter. We can't see it directly, but we know it's there because of its gravitational effects on visible matter. It forms a cosmic web that connects galaxies and galaxy clusters, like an invisible skeleton of the universe. And then finally, after crossing the vast cosmic ocean, we'd see it, another galaxy coming into view. If we chose Andromeda, we'd witness something that looks a lot like our own cosmic home. A magnificent spiral with arms that stretch out like a celestial pinwheel, glowing with the light of 1 trillion stars. But we might choose to visit something completely different. Maybe we'd head for one of the dwarf galaxies. These cosmic runts are like the little siblings of the Milky Way, with just a fraction of our stars, but often hiding surprising secrets. Or we might seek out an irregular galaxy, one of those cosmic oddballs that's been twisted and stretched by the gravitational dance with other galaxies. These cosmic collisions create some of the most stunning sights in the universe. Imagine stars scattered like diamonds across space, with huge streams of gas glowing in brilliant colors and new stars being born in the cosmic chaos. Some galaxies we'd find would be red and old, their stars burning out like dying embers, while others would be blue and vibrant, filled with stellar nurseries where new suns are constantly being born. But is that all? Just planets and stars? Are we alone out there? Right here in our own cosmic backyard, we keep finding new planets around other stars, thousands of them, and we've barely started looking. Some of these worlds look tantalizingly familiar: rocky planets with temperatures that could allow liquid water to exist, just like Earth. Now imagine what we'd find if we could explore not just our own galaxy, but countless others. Each galaxy is like a vast cosmic ocean containing billions of solar systems, billions of chances for life to take hold. If life emerged on just one planet in every 1,000, every million, or even every billion, we'd still find countless living worlds out there. With an entire new galaxy to explore, we wouldn't just be increasing our chances of finding life. We'd be opening up an entirely new book in the library of life's possibilities. What might that life look like? Well, that's where things get speculative. We only have one example of life to work with: what we see on Earth. But even here, life has shown incredible diversity and adaptability. We have creatures living in volcanic vents at the bottom of the ocean, microorganisms surviving in acid pools, and bacteria that can withstand radiation levels that would kill a human instantly. If life exists elsewhere, it would likely be adapted to its own unique environment. On planets with stronger gravity, creatures might be short and stocky. On worlds with thick atmospheres, flying might be the norm. On planets orbiting red dwarf stars, plants might be black instead of green to absorb as much light as possible. And then there's the possibility of intelligent life. If we found it, how advanced would it be? Would they be primitive organisms just beginning to evolve? Or would they be a civilization, thousand or millions of years ahead of us technologically? Would they be peaceful explorers, like we hope to be? Or would they see us as a threat? These questions lead us to one of the biggest challenges of intergalactic travel: the risks. One wrong calculation, and you could end up in the path of a supernova or too close to a black hole. Even if you dodge all these cosmic heavyweights, there's an enemy you can't see or feel: radiation. Out in deep space, it's like standing in an endless shower of tiny bullets, each one capable of piercing your ship's hull and damaging the very DNA in your cells. You can't stop it completely. You can only hope to shield against it enough to survive. But perhaps the biggest risk would be the unknown. We might encounter phenomena we've never seen before, or face challenges we couldn't possibly anticipate. The universe is not only stranger than we imagine, it's stranger than we can imagine. And what about humanity itself? How would we change if we became an intergalactic species? Our cultures, our societies, even our biology might evolve as we adapt to life among the stars. We might develop new technologies we can't even conceive of today, or develop new forms of social organization to deal with the challenges of living in space. We might establish colonies in multiple galaxies, forming a vast network of human settlements across the cosmos. But this raises its own questions. How would we maintain contact across such vast distances? How would we preserve our cultural heritage while allowing for natural evolution and change? Would we remain recognizably human, or would we become something else entirely? And if, and only if, we find other civilizations, should we make contact? If we find primitive life forms, should we interfere with their evolution? Should we colonize planets that already have their own ecosystems? Will we become intergalactic Christopher Columbuses, conquering and claiming everything we come across? Well, to be fair, every time humans have pushed boundaries, it's changed us in ways nobody could have predicted. Look, we've covered a lot of ground here, from mind-bending physics like warp drives and wormholes to the practical challenges of keeping people alive in space for generations. We've imagined encountering everything from supernovas to alien civilizations. But ultimately, this all comes down to one simple truth. We're explorers. It's in our DNA. We've never been content to stay in one place, to accept limits, to stop asking, what's over that horizon? So, if you could jump in a ship right now and head to any galaxy in the universe, where would you go? Drop a comment below and tell me which galaxy you'd visit first. And if you're into exploring the biggest questions about our universe, stick around, subscribe to the channel, and hit that notification bell. See you there.